Hello friends, today in this video we will see the very important concept of fluid mechanics. This is a continuity equation. So the continuity equation is nothing but this is based on the principle of conservation of mass. So the conservation of mass, that means what? Whatever be the quantity of fluid is flowing through a pipe, so that quantity of fluid is constant throughout all the sections of the pipe. So here we can see here, suppose the fluid is flowing through this pipe, and this is the section 1 and this is the sections 2, and here your fluid is flowing through the section 1 with a velocity v1, rho1 this is the density of the fluid, and a1 this is the cross section area from where the fluid is entering. Second part, from where the fluid is exit, and here the velocity is v2, density is rho2, and a2 is the cross section area of sections 2, 2. So here actually we have just defined what is v1, what is rho1, what is a1, and same I have defined what is your rho2, what is your v2, and what is your a2. So this is nothing but this is the parameters of the fluids. So that means what? It's the velocity, density, and area actually. Okay, now the rate of flow of fluids at section. So that means what? Here we have already know the Q. So the Q is equal to, it's nothing but this is your rho, V, and A. So here we will calculate what is the rate, or we'll say the flow rate of fluids through the section 1, 1. So this is V1, rho1, A2. Same, we have to find out the mass flow rate of flow through the sections 2, 2. So this is your V2, rho2, and A2. As we know, this is a principle of conservation of mass. So that means what? The quantity of mass flow rate through the section 1, 1 and the quantity of mass flow rate through the sections 2, 2, it should be same. So here, according to the law of conservation of mass and under the steady state conditions, both the mass flow rate should be same in the sections 1, 1 and the section 2, 2. So now here we will write down the expression of both the sections. So rho1 v1 a1, that's equal to rho2 v2 a2, and commonly we can write this is m dot, and m dot is nothing but this is mass flow rate. So this equation is known as a continuity equation, and this continuity equation, it is applicable for both for the compressible as well as incompressible fluid. Now according to the nature of the compressible and incompressible fluid, we have to modify this continuity equation. So suppose we'll consider the flowing fluid is a compressible, then in this case here the density is not fixed. So that means what? Rho1 is equal to not rho2 equation. This is for your compressible fluid. Suppose we have incompressible fluid, so that incompressible fluid the density is fixed. So the rho1 is equal to rho2. So both sides the rho1 and rho2 is cancel out. The rest part only we have, this is a v1 a1, that is equal to v2 a2. So this equation it is applicable for when the flowing fluid is your incompressible in nature.